Hey guys, Mr. Yisley here. We're just going to begin our notes on Chapter F, beginning with lesson number 1 here. So this should be the page that says lesson number 1, and it's talking about prime versus composite numbers. So in your vocabulary, you should have found that a prime number is really any number that can only be divided by the numbers 1 and itself. So it only has factors of 1 and whatever it is. No other number can be divided evenly into it. Whereas a composite number is a number that can be divided by at least one other term than 1 in itself. So it has at least 3 factors of it. So anytime we're looking at a number, we're really just trying to determine, does it have a number other than 1 and itself that can go evenly into it, and that tells us if it's a prime or a composite number. Now we do have some quick tricks that I just want to review with you to kind of determine factors other than 1, so make sure that you get these down. So we can kind of go through these really quickly in our head as we're trying to figure things out, so we're just going to list out what it is. So when we're trying to consider if 2 is a factor, we know that 2 is a factor if the number ends in 0, 2, 4, 6, or 8. So 2 is going to be a factor if the number ends, not numbers, the number ends in 0, 2, 4, 6, or 8. All right, so if the number ends in 0, 2, 4, 6, or 8, that makes it an even number, which means 2 is definitely a factor of it. We also know that 3 is a factor if the digits of the number, so the digits of the number add to a multiple of 3. So what I mean by this is take the number multiple of 3, the number 18. All right, if we added 1 plus 8, we get 9, and 9 is a multiple of 3. We can do that with any number that's divisible by 3. Take 21, you add 2 plus 1, and you get 3, so there again a multiple of 3. So any number that you can add the digits together, doesn't matter how big the number is. If you can just add the individual digits together and it ends in a multiple of 3, then 3 is going to be a factor. Now 4 is a factor if the last 2 digits are divisible by 4. So if the last two digits are divisible by 4. So can 4 go evenly into the last 2 digits? It really doesn't matter if it has 16 digits in front of it. If the last 2 are divisible by 4, then you know it's going to be divisible by 4. So like numbers like 16 and 1628, right? I know that 4 goes evenly into 28, all right? So that means that it's going to be divisible by 4. It really wouldn't matter if 4 went evenly into 16, which it does, but if it didn't, that's okay. I know that it goes evenly into 28, and because the last 2 digits right here are divisible by 4, then that means that it is going to be a factor of 4 in there. 5. So 5 is a pretty easy one. 5 is a factor if it ends in 0 or 5. So if the number ends in 0 or 5, you know that 5 is a factor. 6 is a factor if 2 and 3 are factors. So if you've already found that 2 and 3 are both factors, then 6 is definitely a factor. And this can be helpful later on in the year when we go to it. If you've already found that 2 or 3 is a factor, you've already determined if it was prime or composite. 9 is a factor if the digits add to a multiple of 9. So if you end up in a multiple of 9, so going back to our situation, 18, 1 plus 8 is 9, that's a multiple of 9, so 9 is definitely a factor. Whereas 21, 2 plus 1 is 3, 3 is not a multiple of 9. So it's only going to be numbers that the 2 digits or 3 digits or however many digits you have, all right, add to a multiple of 9. And then 10 is a factor if it ends in 0. So much like 5, if it ends in 0, then 10 is a factor. And those are just some quick, helpful hints to just remind you of how to find factors quickly without having to list them all out. Now, these will be pretty simple. As soon as you find one of these is true for a number, you know that it's a composite number and you don't have to check the rest of them. Later on in the year, when we start learning about factor trees and doing some other stuff, this will become even more helpful. But just a reminder, these are some quick little helpful hints. So let's move on to our examples here, where we're looking at this, and let me move this up just a little bit. All right, where you're seeing the same thing I am. So example A, 21. So we are looking to see, hey, is anything other than 1 and 21 a factor? Well, I just like to list them out real quick. So 1 times 21, there's the first one. Does 2 go in? Well, it doesn't end in 0, 2, 4, 6, or 8. Does 3 go in? Well, you might know that 3 times 7 is a factor, right? And so we definitely know that this is a composite number. Now, if you didn't have 3 times 7 memorized and equal 21, if we just went to our 3 factor, if the digits of the number add to a multiple of 3, again, 2 plus 1 is 3, that's a multiple of 3, and we could find that out really quick. So if you have your multiplication facts memorized, that's a super big help because you can just find those really quickly. If you don't, then you can use these little tricks just to help you out. All right, so let's check example B and see what we come up with. So 47, what are the factors? Well, obviously 1 times 47. Does 2 go in? Well, it doesn't end in 0, 2, 4, 6, or 8, so it doesn't go in. 3 go in? Well, I don't know of a pair that ends 47, but if I just add these together, 4 plus 7 is 11, and nope, that does not end in a multiple of 3. Is 4 a factor? Well, I know that 7's not, the last 2 digits here, not divisible by 4, so that's not a factor. Is 5 a factor? Well, it doesn't end in 0 or 5, so nope. Is 6 a factor? Well, 2 didn't go in and 3 didn't go in, so 6 is definitely not a factor. Is 9 a factor? Well, 4 plus 7 again is 11. That's not a multiple of 9, so 9 is not a factor. Is 10 a factor? It ends in 0. Nope, doesn't end in 0, so 10's not a factor. Is 11 a factor? Nope. So if I know my multiplication tables, I know that there is nothing other than 1 times 47 using whole numbers that creates 47. So it is not divisible by any other numbers, which means that it is a prime number. All right, well, I'd encourage you to try example C. So pause the video, check it, try it on your own, and then check your answer against mine. So example C here, we've got factors obviously of 1 and 13, but we got to figure out, do we have any others? So does 2 go in? Well, it doesn't end in 0, 2, 4, 6, or 8. Is 3 go in? Well, if I add 1 plus 3, that's 4, not a multiple of 3. Is 4 a factor? The 2 digits divisible by 4? No, 13 is not divisible by 4. Is 5? Doesn't end in 0 or 5, so 5 doesn't work. Is 6? Well, 2 and 3 didn't work, so definitely not. 9? Well, 1 plus 3 again is 4. That's not a multiple of 9. And is 10? Nope. Doesn't end in 0. So if I kept going, obviously 1 and 13 are the only factors that can divide evenly into it. So this again is a prime number. All right, so now I'd encourage you to try example D on your own as well. So pause the video and then check your answer with mine. So again, listing the factors, I've got 1 times 165. That's 1 factors. Does 2 go in? Well, it doesn't end in 0, 2, 4, 6, or 8, so it's not an even number, so 2 does not. Does 3 go in? So if I add the digits, 1 plus 6 is 7, plus 5 is 12, and 12 is a multiple of 3, so that I know that 3 definitely goes into this, which means that it is a composite number. Now you may be saying on this one, well, I saw that it ended in 5 and anything that ends in 5 is a factor of 5. You're right. There are more than 3 terms or 3 numbers here that can go into that. We just need to verify that there's more than 1 in the number itself. And as soon as I realized that 3 was a number that went into it, I had done enough work to identify that it was composite. All right, so this is the type of work that we want to see when you're doing these problems on your assignments in the worksheet. So if you have any questions, please let me know. Otherwise, you've got what you need to proceed forward.